So this lesson is on graphing inequalities. You've learned how to graph inequalities like on a number line before with open and closed dots and shading. Well, we're going to be doing this on a coordinate plane. So it's the same kind of concept, except there are two main things you're looking for. What type of line? Is it solid or dashed? And where is the shading going to be? So what we're going to look at is we're going to be looking at these symbols here. That's greater than, that's less than. And with those symbols, if you see one of those and you're graphing on a coordinate plane, it means you're going to use a dashed line. However, if you see equals, greater than equal to, less than equal to, or just regular equals, that is going to be a solid line. Now, a dashed line looks like this here. Solid line means it's completely filled in. These also relate to the types of dots you would use to plot your points. The dots for this one would not be filled in. They would be open dots. Versus if you have an equals involved, they'll be closed dots, solid dots. Now, if you see the symbol greater than or equal to, it means you're going to shade above. Versus, if you see the symbol less than or equal to, you're going to shade below. Now, some students prefer to do a test point, and I'll show you how to do that as well, and you can kind of pick which method you prefer to use. So in our first example here, notice that we have a less than symbol, which that means that we're going to be shading below the line. So less than, what I always say is where the lesser numbers are. I know that's not grammatically correct, but if it's less than, you want where the lesser numbers are, which would be your negative. So shading below. And then we see the equals part, which means we've got a solid line. So now let's go ahead and find our slope here. Our slope is the number right in front of x, the coefficient, negative 2/3. I'm going to put that negative on top with the 2 over 3. So that tells me I'm going to rise negative 2, which really means I go down 2, always run to the right. And then my y-intercept, the beginning value is 1. So we're going to begin with 1, always on this line. So we're going to put what kind of dot? Well, if it's a solid line, it's a solid or closed dot, so on 1. B is 1. From here, we're going to fall 2, 1, 2, run 3, 1, 2, 3. Fall 2, 1, 2, run 1, 2, 3. And then you want to use that straight edge. We're going to be giving it a solid line. Go a little farther up. And now the last thing we need is shading. We said shading below. So if I put my marker here, maybe this will be a little easier to see, a pencil here. Where is below? Below is right here. So if you can imagine, we're going to be shading right underneath here. Well, if I tilt this pencil to match the graph, you can see that this represents below. So what we do is we take our marker and we shade here. Anywhere below the line is a solution. Now, if you don't like that and you're like, I really prefer a different way, you can use what we call a test point. So let's look at that. A test point here. My preference is generally to use 0, 0 because it's just easy to plug in and easy to work with. So we're going to test 0, 0. The only time you're not allowed to use 0, 0 is if it's actually on the line you've graphed. So I'm going to test 0, 0 by putting it in. 0 is less than or equal to negative 2/3 times 0 plus 1. I plugged it into the y and the x. Let's see what happens. Bring down the 0 is less than or equal to negative 2/3 times 0 is 0. 0 plus 1 is 1. Is 0 less than or equal to 1? Yes, it is. So we shade where it's true. That's true. If it was false, we would shade on the opposite side. In this example, we're going to graph, but we're not in slope-intercept form first. So remember, we want to subtract that 4x from both sides. That leaves me with negative 2y, keep that symbol, is less than, we want that x term first, negative 4x That is a positive 6 here. Now I want to get rid of this negative 2. So how do I get rid of it? Well, we're going to divide every single thing by negative 2, but there's a wait, there's a catch. See, when I divide every single term here by negative 2, anytime you multiply or divide by a negative number, it flips your inequality sign. So we've now gone from less than to greater than. These negative 2's will cancel, and that leaves me with y. Negative 4x divided by negative 2. Negative 4 divided by negative 2 is positive 2 with an x, and 6 divided by negative 2 is negative 3. So I can see my slope is 2, or 2 over 1, so I rise 2, run 1. My beginning value, my y-intercept, is negative 3. And let's talk about dots. See, I see that symbol right there, which is greater than. Greater than means that there's no equals here, which means we've got ourselves a dashed line. And we want to shade where the greater numbers are. Again, think about it like this way. The greater numbers are the positive numbers, so we're going to shade above the line. So let's start by plotting negative 3. If we have a dashed line, we want an open dot. And we're going to rise 2, run 1. Rise 2, run 1. Use that straight edge again. And make sure you make this line dotted, dashed. That means that if there's a point and it falls on the line, it's not a solution. Alright, and we're shading above. And again, let's put that pencil there. And if you were shading here, here's where you would shade, above the line. So if we tilt this pencil to match the line we've created, there's where above the line is. That's where we're going to shade. So we want to shade in this region here. Anything in this region is a solution. Sometimes we get these funky problems like a y equals or an x equals a number, and that goes back to the way we learned how to graph those lines. So remember, a y equals line is a flat line. So we want to find where y is equal to negative 5. But pay attention. That right there, that symbol means we want to shade above, but it also means we've got a dashed line because there's no equals. So the no equals means it's dashed. We're shading above because it says greater than. So at negative 5, we're going to put a dashed line, and we want to shade above it. Sorry about that, I knocked down the microphone. Alright, on this last example, it says graph the system. So now we want to graph two lines and we want to see where they intersect. So let's graph the x is greater than 3. We know it's going to be a line that is vertical. And so we also need to know that it's going to be solid because it's got the equals, so it's solid. And we want to shade where the numbers are greater. Greater numbers are the positive numbers, or in this case it's going to be to the right because of the type of line we're dealing with. So we put a solid line here where x is 3, and we're going to shade here to the right. Now we're also going to do this other line, but I'm going to do this in a different color. So I see that my slope is this negative, or negative 1. Let's put it over 1. And the beginning value is at 3. This right here tells me there's no equals, so it's got to be a dashed line with open dots. And we want to shade where it's less than or below the line. So we find 3, we put begin with the 3, put an open dot, and then we go down 1, over 1, down 1, over 1. So we want to put our dashed line right here. And we want this shading to be below this line. So again, if you need to, put your pencil, say below means it's going to be here, and then turn that pencil and recognize it's got to be right there in that section. So we're going to be shading right here. What you're looking for is where there is a double shaded region. The double shaded region is this section right in here where we have both the brown and the pink. So that means anything in this section with the green now is a solution. It has to be in the double shaded region to be a solution. So for example, the point 4, negative 4 is a solution. That means it works for both of these equations. The number 2, 5 is not a solution. The number 4, 5 is not a solution. The number negative 4, negative 2 is not a solution. It has to fall in the double shaded region.